Okay, now we're going to look at parametric equations going the other way. I have two parametric equations. Again, I know these are parametric because they're in terms of t, but I want to write the rectangular equation. So I want it to say like y equals x and something like that. So what you're going to do is I want this y equals equation because that's the form that I want my rectangular equation in. So I'm going to solve this x equation for t. So I'd have to add the 3. So 3t equals x plus 3. And then to get t by itself, we're going to divide by 3. So all of this is t. So since t is right here and I want it in terms of x, I'm going to plug her in. So now my equation says y equals 2 times x plus 3 over 3 plus 1. I'm going to distribute this 2 through and break up this fraction just to simplify. So that would be 2/3 x plus 6 over 3, which is 2, plus the 1. Combine your like terms. Your equation is 2/3 x plus 3. And then it also says to identify the shape. So if I was to graph this, this would be a line. Yay! So that's how you turn it into rectangular. Let's do another one. So here's my y equation. Let's solve for t. That's x minus 2. Plug it in. And you know when you see something like this, you're going to have to FOIL it out because she is really just this. So we're going to FOIL, FOIL, FOIL. Here's our rectangular equation, and that is a parabola. Any questions so far? Great, let's look at these tricky gals on 3 and 4. So on number 3, I have that cosine and sine thing. So I know that this is either an ellipse or a circle. Well, since the number in front is not the same, I know it's going to be an ellipse. Okay, so for an ellipse, x always comes first. There's nothing added or subtracted, so it's just x squared over 3 squared is 9. Ellipse has the plus sign, so now we'll do y. This has a minus 2, so in my equation we say plus 2. And then 4 squared is 16. It always equals 1. So there's our equation. Same thing over here. I see secant and tangent, so I know it's a hyperbola. And remember, for hyperbola, secant is the one that comes first. So my x value is going to come first, meaning this is a horizontal hyperbola. But again, I just want to write the equation. So x is going to come first. They have a positive 3, so I'm going to subtract 3. 4 squared is 16. Hyperbola is minus. Now let's do the y. Minus 2, so plus 2 over 3 squared is 9 equals 1. Yay! So that's how you would convert from polar into rectangular. So again, you always want to solve for t and then plug into the y equation and simplify. And then when you notice your trig functions, you have to be able to identify whether it's ellipse, circle, hyperbola. Okay, so now let's go into graphing. When you're graphing a parametric equation, your table is going to have 3 columns instead of just x and y because our equations are in terms of t. They will give you an interval, so our interval is always in terms of t. So they said from 0 to 5. So I already filled in your table for you from 0 to 5. If I want the x values, I take each of these numbers, plug them into the x equation. If you want y values, you take each of these numbers, plug it into the y equation. So let's all take a second to do that. So I'm going to start with 0. I'm going to do all the x's first and then all the y's. So 0 into x, would be 0, -3. Plug in a 1, that's 3 minus 3 is 0. Plug in a 2, 6 minus 3 is 3. Plug in a 3, 9 minus 3 is 6. Plug in a 4, 12 minus 3 is 9. And then 15 minus 3 is 12. So there's my X column. Now this is where a lot of you are gonna get confused. Y'all are gonna start plugging in these X's now for Y, but no, Y still has the T, so I still plug in the T. So you're ignoring this column for now and just doing the T values into the Y just like we did for X. So everybody take a second and do the Y column. Are you doing it? I'll wait for you. Don't look. Do it yourself. Did you get this? Wow, good job. Okay, so now I'm gonna graph this parametric equation. Well, my graph is an X and a Y axis, so I don't need T anymore. I'm just using these points to graph. So I'm gonna plot each of these coordinates onto my graph. Okay, now 12, 11 isn't on my graph, but I still need to plot it because I have to go across this whole interval. I can't draw an arrow. So I'm just gonna kind of estimate where 12, 11 would be, put a point, and then connect your dots. The last thing would be to convert this into a rectangular equation. So the same thing that we did above where you solve for T, plug it in for Y, simplify, but I do want to draw your attention so we're not double working. This is the same as number 1. So this equation is 2/3 X plus 3. And you can check your answer by making sure, okay, the slope is up 2/3. The y-intercept is 3. Holler, we did it. Let's do the next one. Excuse me. Okay, my bad here. This should be T squared. They gave me an interval 0 to 4, so I put in 0 to 4. And I'm gonna start plugging these numbers into the X equation and the Y equation, just like we did on number 1. So 0 plus 2, 1 plus 2, 2 plus 2, 3 plus 2, 4 plus 2. And now for the Y, we're gonna square them. 0 squared, 1 squared, 2 squared, 3 squared, 4 squared. Again, ignore the X because you're plugging in T values. So I'm gonna take these coordinates and put them on my graph. Again, you have to include all of them. It's probably closer to right here. Okay. We have to write the equation, but this is number 2 from the top. It's a parabola. So there's our equation as well. But again, if you didn't know that, you would solve for T, plug T in, and then get your equation. And that's how we graph. Turn the page. Okay, we have a couple more, and these are completely blank. So the first thing I'm gonna do is I'm gonna go ahead and solve and write my equation. So I'm gonna get T by itself. So I have to square the other side. So T is just X squared. Let's plug that in for Y. So this is what we're plotting on our graph, okay? So my T values have to start with 0. They have to start with the number that you're given. But for this interval, it could keep going forever, which means there's not necessarily a point I have to stop at. So on my graph, there's gonna be an arrow on the other side. Now, I wanna kind of be strategic when I'm picking my numbers, because if you notice, for the X column, you're gonna be square rooting. So I don't wanna pick a number like 5 because I don't know what the square root of 5 is, okay? So what I'm gonna do is pick numbers that are perfect squares. So 0, 1, 4, what else? 9, 16, that's probably good. I don't care about this box because I'm gonna draw, again, I'm just gonna draw an arrow on the other side. So now let's plug in x values. Square root of 0 is 0, square root of 1 is 1, 4 is 2, 3 is 9, 16 is 4. And then plug in the numbers for y, so 1 minus these numbers. I shouldn't have to teach you how to do this. I believe in you, you got this. And then same as before, plotting these x and y values onto your graph. So 0, 1, 1, 0, 2, negative 3. And then 4 is negative 15. Oh wait, where am I at? 3, negative 8, I didn't do that yet. 4 is negative 15, but I don't necessarily have to plot that because again, what's going on the other side over here? You said arrow? Wow, you would be correct. Okay, let's do one more normal one. This one is negative 4 to 4. So I'm gonna do negative 4 to 4. 0 is in the middle of that. The middle of 0 and negative 4 is negative 2. And then 2 over here. So I just kind of picked middle points. It doesn't matter what points you choose as long as you choose negative 4 and 4. Okay, let's plug in t to the x column. Well, they're the same, so this whole column's just gonna be the same. Now I gotta plug it into y. So I'm gonna square it, make it negative, and then divide it by 4. So negative 4 squared is 16. 16 divided by 4 is 4, but make it negative. Negative 2 squared is 4, divided by 4 is 1, negative. 0 is divided by 4 is 0, negative 0 is just 0. 2 squared is 4, divided by 4 is 4. 2 squared is 4, divided by 4 is 1, make it negative. So same thing here, negative 4. Oh, I haven't written the equation yet, let's do that. Oh, x is t, so this is an easy one. So anywhere you see x or t, there's gonna be an x. So my equation is just this. Now let's plot these points. Negative 4, negative 4. Negative 2, negative 1, 0, 0, 2, negative 1, 4, negative 4. We're not drawing arrows because they gave us a left and a right side of our inequality. So connect beginning to the end. Do not go past 4 and negative 4. Woohoo! Okay, now let's get into some tricky stuff. But we're big boys and girls, so it's okay. So we have 4 sine and 4 cosine. I know that this is either going to be a circle or an ellipse because it has sine and cosine. I know that it's a circle because these numbers are the same, which means this is the radius. There's nothing added or subtracted, so the center is at 0, 0. So my equation is going to be x squared plus y squared equals radius squared, so 4 squared is 16. That's the equation of my circle. Now my interval is from 0 to pi. I know a circle is 2 pi, so my graph's only going to be half a circle. But to figure out where those points are, I'm going to plug in these t values into the x equation and the y equation. Now you have to think unit circle here. So if you do, let's do x first. If you do the sine of 0, that's 0. 0 times 4 is still 0. The sine of pi over 4 is root 2 over 2. Well, root 2 over 2 times 4, this simplifies to 2, so it's just 2 root 2. The sine of pi over 2 is 1, times 4 is 4. 3 pi over 4 is still the root 2 over 2 times 4, that'll be the same thing. Pi is 0, 0 times 4 is still 0. So we got sine done. Now let's do the y equation, that's cosine. So plug in a 0. Cosine of 0 is 1 times 4. This is root 2 over 2 times 4 again, so we'll have the same thing here. Cosine of pi over 2 is 0 times 4 is still 0. 3 pi over 4, this one's different because it's cosine, so it'll be negative root 2 over 2 times 4. And then pi is negative 1 times 4 is negative 4. So here's what I have to plot. Now I know we don't have a calculator for this. So I'm going to tell you that 2 root 2 is about 2.8. So just know that whenever you're plotting these points for x and y. So 0, 4, 2.8, 2.8. Perfect. 4, 0, 2.8, negative 2.8, 0, negative 4. So there's our half of a circle. Cute. Let's do this one. All right. I know that this is sine and cosine, so it's either ellipse or circle. Since they have two different numbers, I know it's an ellipse. So if I'm going to write, there's nothing added or subtracted, so it's just x squared and y squared. The number under x is 25. The number under y is 9. So here's the equation of our ellipse. Excuse me. My interval is 0 to 2 pi, so I'm going to actually graph a full ellipse. Fun. So let's plug in some radians. 0 to 2 pi. Halfway we'll use pi. And let's do pi over 2 and 3 pi over 2. So this should be easy because I'm not going to have any like root 2's over 2's this time. So let's start plugging in our x values into the x equation, or t values into the x equation. Cosine of 0 is 1 times 5. Cosine of pi over 2 is 0. Cosine of pi is negative 1 times 5. 3 pi over 2 is 0. And then 2 pi is the same as 0. So now for the y, we're going to do sine. Sine of 0 is 0. That's 1 times 3. 0. Negative 1 times 3. 0. So let's plot these points. 5, 0. 0, 3. Negative 5, 0. 0, negative 3. And then went back around to 5, 0 again. But obviously I don't have to draw a dot on top of a dot. So here is my ellipse. And that's graphing. Ta-ta!